And this is our first video today about the science that I have for you. Very nice, very nice. And this will be the next thing we're gonna have in a moment. So hopefully you're doing well. This is Saturday, January 27th. And I'm here to answer questions you may have. I've been a teacher for more than 25 years, teaching science at the high school level. And I do know a lot of things, love to share what I know, and I'm here to answer your questions. There you go. So let's see. So the next topic, let's see, I'm going to start again. In the news, you may have noticed Iceland is having some lava flow reaching the surface, being very close to a town called Grindavik. And we're going to talk about, first of all, to see what's happening there. But how come this lava is coming out at that place? I know we've had tremors recorded. We talked about people being evacuated. But how come lava is coming out in that spot? And this is what we're going to talk a little video about geology. So let's see what we're going to learn today. So here, if you notice, we have Grindavik, that is a little town right here by the sea, and we have the lava that is coming up. If I look at some of the pictures, this is an example of a lava flow. And here you can see that's done at night. We have the cooling down of the lava that is a bit darker in color, and then you have the lava that is flowing and crackling. And you can see here that it's following a line. So when you have lava following up a line like this, that means there's a fracture, and then lava is coming through. Let's see if I can have, there you go. So here's another map. So you could see we have Grindavik that is right here at the bottom here of the map. And then you have here a line that shows an infrared map of where we have lava flows. And you could see that it follows here a straight line. Now, if you look at this map, you will notice that this idea of a straight line here is also in this area here, in this area, and in this area here. So there's a linear pattern, and even on the other side, there's a linear pattern about the lava flow in that area. So the whole idea here is what is going on here. So let's see if we can look at some ideas. So here's a map of Grindavik in Iceland. So here I am on Google Map. It shows how it's fairly flat. Now, if I extend a little bit, you can see that it's on the edge here of Iceland. But if I go up here, there we go. And so we have Iceland. So Grindavik is right here. So somehow on this island, we have lava flows right here. And the main question is why there? So let's do some geology to better understand what's happening. So first of all, we're going to look at the geological map about Iceland. So if I go here, you will see that the zone here that is in light gray is the lava flows from our geological era. You will also know that you have those areas here. So we have different kind of basalts. We have basalts here that are tholeiitic. Very good. We have here, no, that was the dark one, alkaline de transition, and we have these lava flow or lava that is in orange. Interestingly enough, using dating technology, we can figure out how old they are. So there's a big band here of recent lava flow, and here in orange we have the most recent one. So how come it's following this part here, and somehow there's a little leg that is going there, and Grindavik is right here at the bottom, and you could see all the lava flows that are linear that follows this trend right here. So let's see if we can learn more about that. So here we have the island. So here we have the Grindavik is right here at the bottom. So right here we have a fault line that is going this way and one that is going here from the northeast to the southwest, and there's another branch right here. Let's see if we can get more details here. So there you go. So we have the island, and we have some fault lines here. Fault lines number 2 and 3, they're old ones. They haven't moved in a long time. But recent one, we have this one here, which is 1N to 1V, and the fault line 4. So these are active faults that are moving. And the question here again, what's happening at the scale of a country, maybe, and in a moment I'll show you at the scale of a planet, to create this lava flow here at Grindavik. So let's see. So here I went to Google Map. Google Map is an amazing place for us to learn. So I'm going to step up so you can see Greenland. We have Sweden, Norway. So here we go. We go this way a little bit. Then we have France, Spain. We have Canada right here. There we go. We have the United States. And I'm going to keep going south a little bit to show you something interesting. Perfect. So if you think of a scale of our planet, you may have heard what we called plate tectonics. So plate tectonics, what it is, we have Earth that is a sphere. And on that sphere, you have rocks that is floating on the mantle. Now, over the last century, we made the recognition that here we have Africa on one side, and we have South America on the other side. Now, if you look at the shape here of South America, so here we have this shape right here, and in Africa right here, we have, in billions of years ago, we'd have this part that was linked to this part here, and it was all part of this supercontinent called Pangaea. And somehow South America and Africa are moving apart. Now, how do we know that for sure? So here on the eastern part of South Africa, we have types of rocks and fossils that are very similar to what we have here in the western part of Africa. So this not just they look like they could fit together, is that we have scientific evidence showing that it is true. So if I look even closer, so that somehow it seems that these two pieces that were together are moving apart. So if you look here in the middle of the ocean, we have what we call the mid-ocean ridge. So here we have a line, and if you see, there's one that is vertical here and some that are horizontal. Now keep in mind that our planet is a sphere. So if you have two things that are moving sideways, what happens is that nothing will go into straight lines. But we know that this part here shows a ridge, it's like a mountain ridge, that shows that it is in a straight line. And here what's happening, it's going apart. We know that because rocks here and fossils are similar to what we had on the other side. So let's see if we can do a drawing to explain that a little bit more. So let's see. South America and Africa. I just mentioned at some point we had South America and Africa that were together, and now I'm saying that they are here, South America, and we have Africa like this. We know that they are moving away from both of them, but because they're moving away, what happened, it creates a region of low pressure. So we have magma from further down that has a place for it to go. So here we have the mantle like this. So what happened, because the two continents are moving apart, it gives a chance for volcanoes, volcanic lava to go at the bottom of the sea. And what happens is that this one here going up, so we have a small ridge right here with the new lava being produced all the time. But interestingly enough, because these two are separating on either side, so here maybe you have 100 million years here, and then you have 300 million years here. And you know what? I forgot the exact date. I should look into that one day. So what happened is that we have two continents. We have the Atlantic Ocean. Those two continents are moving apart. We have new magma coming up here. And then as you go here, you have older and older new rocks that is making the surface of our planet. So let's go back to Google Earth to double check that. So now that I've explained this, you will notice something fun. So if you look here, I get a bit closer. So there you go. So here you've got a ridge, and this part here on the right is going to the right. This part here on the left is going to the left. So what happened is they're spreading apart. And here we've got the tension lines, because being a sphere, it creates those. So as you can see, we have this ridge. So we have South America that is moving away from Africa. But what happens if you go up and up here? So we've got the same ridge all along the Atlantic Ocean. Same ridge here, same ridge here, same ridge here. So what do we have here? We have here France, Portugal, and Spain, and we have Canada and the eastern part of the United States. Interestingly enough, if you like plate tectonics, North America and the European plates are moving apart between 2 and 7 centimeters every year. So that means that if you think of 10 years ago, we were 70, maybe 50 centimeter closer to each other. So at the scale of the planet, it doesn't make a big difference. But over the millions of years, we can see a difference here. So here we have the ridge. We have the European plates going to the right, the North American plate going to the left, and we have new lava coming here, creating new earth crust as we go along. So let's see if I can get closer. So here you can see we have the ridge. So here you can see the ridge keeps on going north, and here we have the Groenland. Oh, look at this. We have this ridge going this way. And if I get closer, this ridge is going this way and this way, all the way to the edge of Iceland right there. But what do we have here? We have Grindavik. So right here is the town that is receiving this new lava coming from the mantle. The reason why it's coming up is that we have on the Iceland island here, we have here the bottom part here, the southern part that is moving south, and the northern part that is going north. And what happened is we have Iceland that is a volcanic island. It's a big island, but still a volcanic island. So what's going on? So we have the two plates that are separating, creating an area of low pressure. And the consequence is that we have a situation where, because this part here on the southern part goes this way, the northern part go up, the low pressure creates a place where lava can just go up. So the whole idea here is that how come this is creating so many issues for this village? The whole idea here is that this fault line has been there for millions and hundreds of millions of years. So what do we have here? We have a village that was installed in the path of this. So that is what we can say about this one. So it's quite amazing. And here you could see that what's happening here in Grindavik. So I don't know if I can show you the little village. So the little village is here, and we have the new lava right there. It is because it is in line with something much bigger that has a planetary scale. And here you can see these two plates are moving along. And the reason why this is happening, it's a planetary scale system, which is kind of amazing. And you can see that this is going up this way. And you can see on the north here, more of the ridges under the sea. So I thought that this would be something interesting. I do love geology. I like the way it works. And this is explaining how come Iceland is getting so many lava and tremors. And it's just because it's at the place where we have to expect that is happening. So hopefully you've enjoyed this video. I'm going to put here a link to another science video. You'll see it's exciting because the more we learn about science, the more we can answer questions, and then it continues the path and journey in learning something more. I'm going to see you in the next video.